In this video, we're going to take a look at simplifying rational expressions. In number 1, it asks us to evaluate 15 divided by 3 by division. So when we have 15 divided by 3, it equals 5. In A, it says write the numerator and denominator of 15 over 3 in prime factors. So we're going to have 3 times 5 divided by 3. And then in B, do the numerator and denominator have a common factor? And it's yes. We have 3 as a common factor. And then what do you notice about the uncommon factor? We notice that the uncommon factor is 5, and that is the same as the evaluation of 15 divided by 3 by division. Next, we're going to take a look at the fundamental property of fractions. So it says let P, R, and Q represent numbers or expressions such that R is not equal to 0 and Q is not equal to 0. Then the following rule holds. P times R divided by Q times R is equal to P times Q. This allows us to divide out like factors. And it says note, to apply this property, the numerator and denominator must be factored. So for number 2, we have a series of examples, and let's take a look at how to apply the fundamental property of fractions. So we have A is 9x divided by 3x, and we can see that x and x are going to cancel, so we're left with 9 divided by 3, which is equal to 3. In B, we have x plus 9 divided by x plus 3. And here the fundamental property of fractions will not apply because x plus 9 and x plus 3 are not factors. So in C we have 2 divided by 6x plus 2. And what we're going to do is factor out a 2 in the denominator. So I'm going to rewrite this as 2 times the quantity 3x plus 1. And now the 2's will cancel out, and we'll be left with 1 divided by 3x plus 1. In D, we have 3x plus 1 divided by 6x plus 2. And I'm going to do the same step I did last time. I'm going to divide the denominator by 2. 3x plus 1 in the numerator, and then 2 times 3x plus 1. And when we do this, the 3x plus 1 factors cancel, and we're left with a 1 in the numerator and 2 in the denominator, or 1/2. In E, we have 5x minus 4 times 2x plus 1, all divided by 2x plus 1. And we can see that the factor of 2x plus 1 is in the numerator and the denominator, and that we're left with 5x minus 4. Now be careful about the placement of the parentheses. Here we can see the product of 5x minus 4 times 2x plus 1 are multiplied by each other. In this next problem, we have 5x minus 4 times 2x plus 1. So we're going to multiply this negative 4 through the parentheses, and that this is not the product of 5x minus 4 times 2x plus 1. And that's how this problem differs from that last one. So we're going to have 5x minus 8x minus 4 divided by 2x plus 1. And when I simplify, I get negative 3x minus 4 divided by 2x plus 1. And both of these are factored as far as they can be, and nothing here is like from the numerator and the denominator. So this one is written in its lowest terms. In example G, we have x squared plus 3x plus 2 divided by x squared plus x minus 2. So in this problem, we need to factor both the numerator and the denominator. So we have x plus 2 times x plus 1 in the numerator divided by x plus 2 times x minus 1 in the denominator. And the x plus 2's, we have a factor in the numerator and the denominator, so they cancel. And we're left with x plus 1 divided by x minus 1. In h, we have x cubed minus 3x squared plus 2x minus 6, all divided by x squared plus 2. And in this problem, we're going to have to factor by grouping. So I'm going to factor an x squared out of the first two terms in the numerator. So I have x squared, and when I do that, I'm left with an x minus 3. And then I'm going to factor a 2 out of the second grouping, so plus 2 times x minus 3 divided by x squared plus 2. And now when I rewrite this, I have x squared plus 2 in the numerator times x minus 3 divided by x squared plus 2. And the x squared plus 2 factors out of the numerator and the denominator and cancels. And now we're going to be left with x minus 3. And that's how we simplify rational expressions.